Now, after knowing some of the basics related to the computers, there are few important topics related to computing that we need to understand. So let's try to go through all these topics one by one. So what are these topics? There are four specific topics that we'll take here. One is cloud computing, then second is supercomputers, third is blockchain, and then fourth is quantum computing. So these are the four important concepts related to computing that we are going to have a discussion on here. So first is cloud computing. Now when you talk about cloud computing is one of the computing techniques which has become very common in today's world. If you have heard of things like Google Drive or Microsoft OneDrive or Apple iCloud or Meghraj, all these are examples of different kinds of clouds. So what is the meaning of cloud computing? So cloud computing is where you are doing the computing or you are storing the data, etc., at a centralized location which can be accessed by different systems. What's happening here? Let's say there is a piece of information that has to be shared among 10 different people. Alright. Now this piece of information or this data is almost of, let's say, 10 GB. Now if everyone had to access this data separately, then everyone will need 10 GB of data on their respective systems. But instead of that, what can be done is that we can provide a central system or a central location which will be shared among all these 10 different users. So all these 10 different users can go to that center, go to that server, access the information from there and come back. So they will not have to store the information at their respective computers. This is what cloud computing is. That instead of storing the data and all the things in different computers, you are having a one single location where all these data is available. So this really saves the space, saves a lot of time, makes the computing much faster as compared to if it was not a shared system. So that's where we typically find the use of cloud computing. So cloud computing is the delivery of on-demand computing service over the internet. Alright, so that's why we are saying that there will be one central location where this data will be located and this will be shared via different users. This will be shared with different users. Everyone can access it. Just imagine or think of your student portal. Right. So in your student portal, what happens? That all the data, all the PDFs, all the links for your webinars, etc., each of these things are stored at a central system, at a central location, and you have a login ID and a password to access all the pieces of information that's there. Otherwise, you would have needed a laptop or a tablet or a mobile phone which has more than 100 GB of space so that all these data can be transferred individually to all your computing systems. But instead of that, there is a central cloud which has all this data. You just have to log into students.byju's.com, go there and access all the data that you need. So that makes it much easier for you to handle all this data and make the computing that you needed here much easier. Otherwise, each one of you would need computers which has so much of data, which can store so much of data. So that will also become very cost intensive for you. Right. So this is how computing works. This is how cloud computing works. So rather than owning their own computing infrastructure or data centers, companies can rent access to anything from applications to storage from a cloud service provider. So what are the benefits? Cost, performance, better security, speed, productivity, reliability. All these are different benefits that we can get out of it. So cost aspect, as we discussed, that if each one of the users need their own computers or own computing systems, then of course the cost to company will be much higher. Then after that, the performance will be much enhanced, much faster, easier, because everyone does not need to have a specific configuration. Everyone can have the access to the central location. Better security can be provided to the servers. The chances of data leakage is much lower, right? So that's another part. Speed, we already discussed that speed will be enhanced because there is a central system where everyone is accessing it. Productivity can increase and even the reliability of the entire system will be much better. So all these are some of the advantages that we will have with cloud computing. So Types of cloud, there are three: public, private, or hybrid. Public, where the information can be shared across the terms. Private, where the information to be shared is to be secured among the groups of people who can only have the access. So that is where private cloud will work. And then we can also bring in hybrid systems, which will be having both the properties of a public cloud as well as private cloud. Examples, we already discussed the examples: Google Drive, iCloud, OneDrive, Dropbox, Meghraj. All these are examples of cloud networks. Alright. So just understand this, that instead of everyone having their own computing systems, there will be a central location where all these information will be available. Then the next topic for us is supercomputers. Now, when we talk about supercomputers, the name itself suggests that it should be a kind of computer which perhaps has a better performance or a better speed as compared to the normal computers. This is exactly what happens here. So our normal general computing systems, they are meant for general purposes, our day-to-day activities, for our maybe personal use or professional use or anything like that. Correct? But when it comes to supercomputers, supercomputers are very specific in nature. They are developed for something very specific. For example, they could be built for monitoring the climate change or monitoring the weather patterns so that we can understand how climate change is happening. So for that, it would need a lot of data processing. Processing of each and every second, and that too needs to be done very quickly. So for that, you need some special purpose computers which can compute data much faster as compared to our general purpose computers. So this is where supercomputers come into the picture. So supercomputer is a computer that performs at or near currently highest operational rate for computers, and they are employed in specialized application which require large amount of mathematical calculations. So this is where we see supercomputers largely will be used, that they will be used for something very specific. They will not be used as general purpose computers that we see normally. Correct? So their computational speeds will be very fast. Normally the speeds are calculated in petaflops. What is the meaning of petaflops? Flops basically stands for floating point operations per second. Now, floating point operations per second is the amount of calculations that can be done, around amount of arithmetic calculations that a system can do. Those are called as floating point operations. Alright. So amount of floating point operations that can be done in a second is how we compute the speeds of a computing system. So for example, you start with mega. What is mega? Mega is 10 to the power of 3. So that's why when you say MB or megabytes, so megabytes or megabits, it basically stands for 10 to the power of 3 or 1000 bits or 1000 bytes. Then after that comes hexa, correct? So hexa is 10 to the power of 6. Then after that comes giga. So giga is 10 to the power of 9. Then after that you have tera. So tera is 10 to the power of 12. And then after that comes peta. Peta is 10 to the power of 15. So for example, when you say that my hard disk has a space of 1 TB. So 1 TB is 1 terabytes, meaning 10 to the power of 12 bytes of space is there in your storage device or your hard disk. Correct? Similarly, when you say GB, so GB is gigabytes. So this is how we basically do the calculations. So mega, hexa, giga, tera, and then you have peta. So when we say petaflops, we are saying that 10 to the power 15 type floating point operations per second is the way in which we calculate the speed of a supercomputer. So currently you have Fukagu. In 2021, Fukagu was named as the fastest supercomputer in the world, having a speed of 442.010 petaflops per watt per second. So that's why this is the highest computing speeds that we have in the world currently. That is, fastest supercomputer is Fukagu, which belongs to Japan. Now, if you talk about India, first Indian supercomputing program started in 1987. We started to build supercomputers for specific purposes, for weather monitoring, for agricultural monitoring, for all these purposes. We started building our own supercomputers. Currently, the highest speed in supercomputers in India has been seen as 6.8 petaflops. Now 6.8 is a very low speed as compared to the highest supercomputing speeds that we have seen in the world. So right now Indian supercomputers do not even fall in the top 50 of the fastest supercomputers. But we have our national supercomputing mission, under which we are trying to build better supercomputers, much efficient, much faster supercomputers today. So maybe as a part of current affairs, this is something that you need to follow if you get any update on a new supercomputer which has been rated as the fastest supercomputer of India or even for the world. But as of 2021, this is the information that we know. So as we discussed, we have the National Supercomputing Mission. What do we want out of National Supercomputing Mission? We want to build faster supercomputers so that we can stand with the world where the supercomputers are. So this is what we are trying. We are trying to build the infrastructure with regards to the supercomputing so that we can build more and more of supercomputers that can be used for various applications in India. We also want to empower our scientists and researchers with state-of-the-art supercomputing facilities so that they can be empowered to build better supercomputers in the coming years. Then after that, also to minimize the redundancies and duplication of effort and optimize the investment in supercomputing, and to attain global competitiveness and ensure self-reliance in the strategic areas of supercomputing technology. So these are the four objectives that we are looking at with regards to our national supercomputing mission. So if you look at the application areas: predicting climate change, studying space and universe, new material engineering, pharmaceutical research, data mining, seismic analysis, atomic energy simulations, disaster simulation and management. So all these are specific applications. Just understand, why are we looking at all these application areas? Mainly because all these are the application areas which need a lot of data processing. They need a lot of data processing. So that's why these are the specific application areas that we are looking at. So for example, predicting climate change. So for that we need day to day, or rather not day to day, but rather hour to hour weather pattern changes over a period of time. So all the satellite images being sent, all the data being received, all the data being collected on the ground, everything has to be computed and everything has to fall into a pattern. Then only we'll be able to compute what's happening and understand what are the weather patterns or climatic patterns so that we can predict climate change. So that's why this is not something that can be done by normal general purpose computers. So this is where supercomputers can come into the picture. Similarly, if you talk about studying of space and universe, we keep on collecting a lot of data with regards to all the celestial bodies and the entire space. So to understand what space is and the universe is and how it functions, we need to process a lot of data and understand the universe from that perspective. So that's why for all these purposes, we need supercomputers, and supercomputers will help us get to the data and the results much quicker as compared to what a general purpose computer perhaps would have done maybe in 10 years or 15 years of time. So that's why all these are the application areas where we see the importance of supercomputers. Now the last topic of this chapter is quantum computing. Now what do we mean by quantum computing and how is it going to be helpful? Let's try to understand this. First of all, this is being called as quantum computing mainly because we are going to use the concepts related to quantum physics here. Quantum mechanics or quantum physics, the concepts related to it. Now what do we mean? Generally, when we talk about quantum mechanics or quantum physics, when does quantum physics come into the picture? Normally speaking, when you talk about the macro level or your day-to-day observance of the space around you, there is something called as Newtonian physics. Alright, Newtonian physics that we use in our daily lives. You might have heard of the 3 laws of motion given by Isaac Newton. This is the kind of physics that is applied to our day-to-day lives. But when you go to the atomic level, when you go to the level of atoms and the subatomic particles, this normal physics that we have read, this physics is not applicable there. This normal physics, general physics, or in other words, Newtonian physics, is not applicable there. So there the laws of physics are completely different as compared to what we see in our day-to-day lives. So this is called as quantum physics. So quantum physics basically works at atomic level. Atomic, or you can say subatomic level. So the kind of physics that works at atomic or subatomic level is called as quantum physics. Now the rules and laws of quantum physics are very different from what we see on ground or what we see at a macro level. So there are very specific properties that we can see with the subatomic particles that will never be seen in a normal particle that we see around us. So that's why the laws of physics are completely different. And the kind of computing that works according to the laws of quantum physics is called as quantum computing. Now, why do we need quantum computing, and what is the advantage that quantum computing gives us over a normal general purpose computing or even over supercomputers? Here, what happens is, when we talk about quantum computing, first of all, they are machines that use the properties of quantum physics to store data and perform computations. Now, when we talk about quantum computing, it gives us a lot of advantages. And now when we talk about quantum computing, it gives us a basic advantage, and that's the advantage of computing speed. That the kind of speed that a quantum computer can provide us is unmatchable. Even the fastest of the supercomputers cannot match the speed of a normal quantum computer. Why so? That basically is because of qubit. Now, generally speaking, we have discussed about this when we discussed the basics of computers, that computing is done in terms of bits, correct? And these bits are in form of zeros and ones. Anything that a computer understands in the language of zeros and ones, which we have also discussed that are called as low level language, correct? What we speak, our English or any other language for that matter that you might speak, this language is called as high level language. So when you give an instruction to the computer, you give in high level language, correct? And this gets converted into a low level language in terms of zeros and ones that the computer can understand. So that is called as bits. In case of quantum computers, we have the concept of qubits. What's the difference? Let's say if I talk about a normal computer, let's say there are 3 bits. Alright. So these bits will be in terms of zeros and ones. So what are the states that you can get out of 3 bits? You can have a state called as 0, 0, 0. You can have 0, 0, 1, 0, 1, 0, 1, 0, 0. Then 0, 1, 1, 1, 0, 1, 1, 1, 0. And then finally 1, 1, 1. So in total you get how many? You get 8 states. Now this directly can also be calculated. This basically becomes 2 to the power of 3, which is 8. So if there were 4 bits, for example, let's say there were 4 bits, then in that case the number of states that you will get will be 2 to the power of 4, that is 16. Alright, it will be 16 in total. So this is how you get. Now in normal computing, what happens is that the computer system will go to each of the states one by one. That first it will go to 0, 0, 0. It will examine whether 0, 0, 0 is the correct answer or not. If it is not, it will go to 0, 0, 1. Then from 0, 0, 1, it will go to 0, 1, 0. And in this manner, one by one, sequentially this will be done. Alright, it will be done sequentially one by one. So computation will happen like this. Now in case of qubits, what happens is that it will not happen one after the other, but instead when we are talking about qubits, all states will be examined at once. So what happens now? Let's say in this case, in case of a normal computing, if each state was taking 1 second, then in total, by the time you reach the last state, you take a total of 8 seconds for the computation to happen. In this case, what happens? Because all states are being computed at once or being looked at once, what happens is that everything still will happen in 1 second. So if there are 16 states, it might have meant that it would take a total of 16 seconds. But in case of quantum computing, it will still take just 1 second. If let's say it was 2 to the power of 5, that is 32 states in total, it would have taken 32 seconds in total. But in case of quantum computing or qubits, it is still happening in just 1 second. So that's the advantage that quantum computing gives you. That quantum computers will be able to compute a lot of information in a very short span of time. It will be able to give you the computation within a second, what a normal general purpose computer or even a supercomputer may not have been able to do in its lifetime. Meaning that something that perhaps a normal supercomputer also might not have done maybe in 10 years of time will be done by a quantum computer maybe just in a second or maybe in a few seconds. So that's the kind of speed that we are talking about. And this is a concept which is also called as quantum supremacy, or another term which is called as quantum advantage. Now, quantum supremacy as a term was being used for reaching a state where a quantum computer is able to give you the output that a normal computer may not have been able to give in its lifetime. So if that can be done by a quantum computer, then in that case it is called as quantum supremacy. But quantum supremacy is a term that was not really liked by many, because supremacy is also a term which has a negative connotation on it, because it is used in racial supremacy, etc. So that's why supremacy is a term that generally is tried to be avoided, and that is replaced by another word, that is quantum advantage. So quantum advantage and quantum supremacy mean the same thing, just that because quantum supremacy has a negative connotation to it, because it is used in racial supremacy, etc. So that's why quantum supremacy as a term is being avoided, and quantum advantage is the term that we want to use whenever such a scenario comes where a quantum computer is able to do a kind of computation that a normal computer may not have been able to do in its entire lifetime. So this is what quantum computer is about. So there are two underlying principles. One is the principle of quantum superposition, and the second one is quantum entanglement. What is the meaning of superposition? So in case of superposition, what happens is that there are n number of works which are being done at once. So for example, let's say you know how to play two different musical instruments. All right, you know how to play a guitar and you also know how to play a tabla. So maybe sometime you want to play a guitar, sometimes you want to play a tabla. But there also comes a time where with your left hand you are able to play the guitar, and with your right hand you are able to play the tabla, and you are able to do both the things at the same time. This is what superposition is. That guitar would have given you one kind of music, tabla would have given you one kind of music, but when you are playing them both at the same time, it gives you a third kind of music, and it is giving you also the music that would have been generated by both the musical instruments at the same time. This is what superposition is. That in case of quantum computing or in case of quantum physics, what happens is that a subatomic particle is able to go through different states at the same time. So if you have heard of, for example, Schrodinger's cat, we talk about the fact that we say that cat could be dead or alive. It could exist in both the states at the same time unless we know what the state is. So this is what superposition does. That a subatomic particle will be able to exist in different forms in different states at the same time. So with this, what happens is that when we talk about quantum bits or qubits, all these qubits can also be computed at the same time because of this principle of superposition. So that's why this principle of superposition is something which is very, very unique, something that is not seen at the macro level, but is something that is seen with subatomic particles. The second concept is the concept of entanglement. So in the concept of entanglement, what happens is that if there are two particles, there are chances that there are two particles which are connected to one another. How are they connected to one another? If you do something to one particle, the other particle will also be affected. If you try to hack one particle, the other particle can also be hacked, or other particle will also show the same thing. So that's why if, let's say, somebody tries to hack the particle at receiver's end, the transmitter end will also see the same kind of a problem, and anyone who is running the system will quickly understand that somebody is trying to hack the system. So that's why wherever you use quantum entanglement, it can make way for a hack proof communication system. Recently, a couple of years back, it was in news that China for the first time has been able to build a hack proof communication system. This basically was achieved with the help of quantum entanglement, where there are two particles which are related to one another, and if somebody tries to do something to one particle, the other particle also gets affected. Right? So this is basically what happens with quantum entanglement. So that's why just remember that these two principles of superposition and entanglement, they are key to quantum computing. Now, what also happens is that quantum computers are very highly sensitive, especially here we are talking about the qubits. These qubits are very highly sensitive. They can be destroyed very easily. Heat, electromagnetic fields, collision with air molecules, all these can cause qubits to lose its quantum properties. This is something which is also called as quantum decoherence. And because of quantum decoherence, we always take extra qubits. If, let's say, there were 5 qubits required for a computation, we keep 7 qubits. We assume that 2 qubits will definitely be destroyed because of the external conditions. So that's why we always try to maintain a very specific condition. The temperatures are kept at very low. I mean, the temperatures will be almost at absolute zero. That is almost at minus 273 degrees Celsius. We try to keep temperatures that low. Then the conditions are maintained, well maintained. Outside conditions or environment will not be able to harm the quantum computing system. So we have to ensure that all these things happen. So quantum computers need to protect qubits from external interference either by physically isolating them or keeping them cool or zapping them with carefully controlled pulses of energy. And at the same time, additional qubits are always needed to correct for errors that can creep into the system. So that's why these two things become very, very important. That first, we have to make sure that the system is isolated from the outside, from the external environment, so that the qubits do not get destroyed. And that's why in any case, if something like that happens, we always keep extra qubits so that those extra qubits can replace anything that can get damaged. Application. When you look at the applications will be very similar to what we anyway discussed for supercomputers, but they will give you much faster results as compared to supercomputers. All these different areas which are again really highly intensive and need a lot of data processing, all these are the areas where quantum computing can be used. All these are the areas where quantum computing can be used. So all these can become applications of quantum computing. Alright, so this basically brings us to the end of this chapter. Now always remember that this is a chapter which always will be very, very dynamic for you. Questions, a lot of questions have come in the past, specifically in the prelims examination. In the mains examination, we have not seen questions coming from here, but many of these areas that we are discussing, for example, they can simply ask you working of blockchains, or they can ask you specifics about quantum computing, or what is quantum computing, what is the principle on which quantum computing works, what is the advantage that quantum computing gives you. So there are n number of ways in which question can come in your mains examination also, and they can ask you very direct questions from whatever we have discussed in this particular chapter. So please make sure that after you end the chapter, you also revise everything that we have discussed. So Remember that this is also a chapter which will need a lot of current affairs updates from your end from time to time as well, apart from everything that we have covered in this particular chapter. So this brings us to the end of this chapter of IT and computers. Thank you.